and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight you're either going to fall back in love or we're going to have you fall even harder in love with your TI-84 plus CE graphing calculator, something that you didn't even know that you need to fall in love with. But the two people that just shared their video are the only two people in the world that could possibly do this for you. With us tonight, we have Corey Bobby and Tracy Watson. These two are definitely a dynamic duo. They've been teaching for a long time, lots of different math backgrounds. Tracy's still in the classroom, and Corey has voluntarily decided to teach online. There we go. They clean up nice sometimes. Right now, they're wearing some very special shirts, which I'm sure you can see. Corey, would you mind talking through our agenda for tonight?
Sure thing, Mike. Well, we're gonna do a bunch of different things. Some of them you may have seen before, but hopefully we'll dive deeper into a couple of them. We'll start with the home screen, do some of the templates on the home screen and play around with some commands. Then we're going to do some graphing in playing with the window. That's one of my personal favorites. Then Tracy is going to take us through some geometric transformations because she loves the geometry and the statistics. And then finally, we'll wrap up with the inequality graphing application.
Thanks so much, Corey. And Tracy, would you talk through our expected outcomes for tonight?
So we're hoping by the end of the night, besides saying that you fell back in love with your TI-84 plus CE, that you will be able to actually use those built-in math templates with your students, graph functions, and explore a lot of features. Some of them you've seen before, some of them hopefully we'll show you some twists on some of them. We will use lists to generate and perform an awesome geometric figure transformation. Can't wait for that one. And then we'll use the inequality graphing app. So you'll see a theme throughout tonight. Our t-shirts, we have to show you the corgi because we're wearing our love t-shirts tonight. So,
and believe it or not, my Valentine isn't just my corgi, but you know, we'll talk about that a little more as we can.
Thanks, Tracy. We're expecting a large crowd, so your audio is muted. Feel free to send any questions to either the Corgi or Tracy or Corey using the Q&A window on the right side of your screen, and we'll also use that chat window to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. All right, without further ado, Tracy and Corey, it is all yours. Feel free to share your screen.
Okay, awesome.
Okay.
So we really hope that you're ready to get back to school. I know I am. I'm in PD this week. Next week, I see our first group of kids on campus, and then they all come back the following week. And so I'm real excited to kind of get going. So what we thought for getting back is the first thing you need to do, I hope you had some serious downtime this summer and that you might even have trouble finding your calculator, so much so that when you find it, you really just need to dust it off. And then find your second calculator that you need to dust off. And maybe your third calculator, however many you have, dust them off and let's get excited. Along with our students, when they come back in our classroom, we need to get them excited about class. And I think this is one way to do it, using your calculator just to kind of jump back in and just show your love for the math through your calculator. So that's what we're hoping to do tonight, besides all those agenda items and expected outcome stuff, you know.
Yeah, that's what they want. You know, we wrote this back. They asked us to present the session months ago, and all we knew is that it would be a little bit after our 25th anniversary. So we've been enjoying 25 years and doing some crazy things with our presentation and with our corgi.
And so that's why we thought this would be perfect, calling it Falling Back in Love. We're at 25 years. Yes, we made it. We're going to go 25 more. I think.
So I think Tracy's going to take us first through some of the home screen, and because we've been married for so long, we do like just step on each other and kind of don't even respect each other's boundaries anymore. So
and it's okay.
it's
like
okay.
each
Yeah,
other.
we actually really do like each other. So we're probably going to interrupt each other and from time to time, but I will try to be good and let Tracy start. I'm gonna go play with the corgi right now.
Okay, so just so you know, there you will get the document, a link to the document that we have, but it's actually going to change after our session tonight. I've got a smart that will be throwing screenshots in as we go along to create the final document. So right now, if you had the link and if you have it, great, it's kind of boring because there's nothing really there. So we're going to be capturing what we're doing. So let's go and actually jump into the home screen. And what we're going to do is I want to make sure, because I'm actually very amazed sometimes that my students, I get them from all over the state of Arkansas, come to me at a residential campus of
We actually
things that they don't know.
Yeah, maybe we ought to like. We didn't even introduce ourselves. She teaches. And it was kind of she's
Quick.
really quick. I mean, it really relates to because Tracy teaches the Arkansas School for Math, Sciences, and the Arts, and she gets students from all over the state. It's a residential high school, so she has students with a varying background. And like Mike said, I teach online. I choose to teach online at the Arkansas Virtual High School, or the Virtual Arkansas High School, anyway. And I have students from all over, so we never really know what our students know.
And I also remember from Benton sometimes where my former school, sometimes there was a difference from what students knew in the classroom depending what teachers they've had. So there are a couple of kind of foundational things that I want to expect my students to know on the calculator. Well, if I want that to expect them to know, I should show it to them. And so this is where I think the start of the year, we're brushing off that calculator, getting the dust off, and just going to show them some math stuff in a fun way without the I'm going to be testing you on this later. That way, when they have this tool, I always call it a learning tool, they're familiar with some of the foundational things I want them to know. So the soft keys, the calculator soft keys are phenomenal when this was introduced on the calculator. So you can type math as math looks on the calculator. So we're going to start with the first round of soft keys, and this is where the notes will kind of be helpful. We'll hit the alpha y equals.
And this is the way it's been for a long, long time.
And so we can do fractions. Actually, just a teacher last week, she did not realize you can do mixed numbers on the calculator. Number 2 is mixed numbers. If you do mixed numbers, you can convert between fraction and a mixed number, vice versa, go both ways. And notice there's also the fraction to decimal built in here. So even if you've seen these soft keys, make sure you stop and look and remind yourself, because it's been summer.
And it has,
What's
well,
there?
and it's also, there's some ones you don't use until you get taught, get a new class to teach. And then you're like, oh, maybe it is there. Like the probability ones. I didn't even realize that. So anyway.
So we're just going to quickly add a couple of fractions. I have the problems over on the Smart. I want you to pay attention to how I'm using the keys. And I try, because I know how all the templates work, when a student types the 1 for the numerator, notice the icon, and I'm going to blow it up just for a second. The icon is a right arrow. So the intent is students to use the right arrow to move down to the denominator. Yes, they can use the down arrow, but this is designed because of some of the other templates and how mathematically you read the math.
And all of the math templates have this. If you use the right arrow, it always will take you to the next logical space. I always would try to do the left and right. I end up pressing a lot of arrows, especially when I get to something like a matrix. But
yes.
So
I'm going to just go ahead and type this. And the nice thing I tell students is when you enter a problem completely in fractions, it's going to give you a fraction back.
Okay, so fraction in, fraction out. Now, go back and grab that command. Go back up.
Problem, okay. I'm going up in my history now. What do you want me to do with it?
Press enter to copy it.
That brings it down into your workable area. So now it's not history anymore. It's a copy of something you did in the history.
So you can bring things down. It could work. She could have brought down an answer if she wanted to. Now I'd like you to add, I don't know, maybe 1/2.
Okay.
Add another fraction, but this time use alpha x.
This is something I tell you,
Yeah.
I had to be reminded about 4 or 5 times before I remembered. This shortcut alpha x is because we use fractions so much, they gave us something even quicker than doing the math template soft key stuff. Alpha x. Now, if you look at your calculator, you may or may not have this little reminder here as the second functionality of xt theta n. I don't know if they're able to see
Yeah,
that.
you may not be able to see it. Mine doesn't, but mine.
One of his calculators that I found on here does not have this. And so, but the functionality still works.
Once you do an
Once
OS
your
update.
OS update, it's still going to work.
Now I want you to do 1 and then do 2 decimal point.
Why do you want me to do 2
What?
decimal
Now
points?
it's no longer a fraction. If you want students want a decimal answer, they can put a decimal point anywhere in. So now this is what you were saying about fractions in, fractions out. This is no longer a fraction command because we've added a decimal. Even though I put 2, I didn't put anything after the decimal point. It is now going to respond with decimals.
So even though there is that under the math menu and that soft y1 equals thing, there is this fraction to decimal. They really don't need to use those. Putting a decimal in any problem will force a decimal out. It's a way that the calculator, you're telling the calculator, I want a decimal answer, please, thank you. So here again, little tips, and some of that you may not have known. Now you know, share it with your kids. Okay.
Moving on.
I think we've exhausted that soft key, the alpha y equals. Let's go to the next one, alpha window. Again, whoop, alpha window. Thank you. Look at all these possibilities. We've got absolute value, summation, and derived.
Calculus.
You're doing that
Yep.
for calculus
Yeah,
this
calculus.
semester.
Yep, we love this one.
Integrals, logs of various bases, general radicals, and then what he was talking about earlier, some statistics, permutations, combinations, and the factorial. So they're all very handy. I chose to kind of go a little bit algebra-wise, where I'm going to do the absolute value. Teach your students to use the negative button, okay, instead of the subtraction, and vice versa when it's appropriate. I couldn't come up with anything more interesting with absolute value.
I mean, yep. And I mean, this was always, I had to go to the catalog or go to math num, but absolute value comes up a lot. And then there's lots of issues possibly with parentheses that you'll need to watch out for. But
the logarithm, this is the one that I think is phenomenal. We do not have to teach the change of base formula unless you want to for historical neat purposes. Depends on my group of kids if I even talk about the change of base formula anymore. Sometimes I do. Yep. Sometimes they find it very interesting how things have evolved from this ability that this calculator has to do some things that only in some settings have learning purpose, I think, nowadays.
You use 2s and 5s a lot too.
But I wonder why I use 2s and 5s.
Anyway. All right. So there are a couple screens there.
Yeah.
Oh, by the way, within the Smart View, what did I just do?
How did you get that screen over there?
You see this guy over here? What I just did was I drug the screen off of the Smart View right into...
Grab it, drag and drop.
And we both have used smart boards in the past.
It'll go into Word, it'll go into Google Docs, Google Slides.
You have to do a screen capture, just drag the screen. Okay. So...
The one that I do want to show you is the matrices. This again was another thing last week. A teacher didn't know that was on here. If I do the soft key alpha zoom, then
dragging that graph is definitely cool.
That alpha zoom gives us matrices where we don't have to store it in A, B, C. I mean, we can actually put the matrices right on the screen. I'm going to do a 2x2 first. And the other cool thing is if they don't know how to do the size, they're going to visually see, yes, this is what I wanted. If they get the rows and columns mixed up, they're going to actually see that they chose the wrong one. Here, when we read a matrice, we read row by row, And so that's again why the right arrow scrolls through the matrice template, how we would read it if we had to read a matrice to somebody.
This is definitely the way I like to talk about the right arrow, or where the right arrow comes in handy. Because
Yeah.
you arrow down and back left, especially in larger matrices, it can be annoying to use the up and down arrows to get there.
And this is where, again, if I don't know my rows and columns, which is which, I don't want to mess up because I kind of do 2 rows, row by column, row by column. Okay, remind that in my head. I would actually visually see I chose the wrong one. Now, I put the multiplication in between. You don't have to. I just like reinforcing that when they're next to each other that it is multiplication, but you could leave that off if you wanted. So,
Okay.
I think.
And you can do other things like determinants and row reduced echelon form commands before you create a matrix.
Yes.
So if you still are storing matrices into A, B, C, and D, stop.
Yeah, you don't need to anymore.
You don't need to. I mean, there's still value to that for some times and certain things, but this is so much faster.
Yeah. Maybe if you're going to be using a matrice for 10 problems, but nowadays we're going to give them 10 different matrices to work with instead of repeating the same ones. So, okay. The last soft key, batch of soft keys would be the alpha trace button. These we're going to hold off till later. These are easy ways to get your graphing variables y1 to y0. Now, I tell students they don't have to remember which button on the top it is. If I hit alpha 1 and I don't see what I'm looking for, you can just scroll right to those other soft key windows. I mean, I honestly, I had to look at my notes to know alpha and then use the correct key. I just say, get your soft keys and then find the one that you need. I'm not going to stress because it's easy to find them.
This makes sense if I have an old school flip phone, but yeah.
Yeah, those of us that remember that, the kids get this real nice. But again, do not forget, and I'm going to say it again because it's one of the things that took me out here a bunch of times. Alpha xt theta n gives you the automatic fraction.
Yeah.
So nice. Even if you don't have it showing, as long as you're updated your OS and don't have it showing on your actual calculator, it is there. So cool. So cool.
Have you drag and dropped the screen into Google Docs? One of the people asked the question.
I
thought I had. I thought I just drag and drop. I know I've done it into Word and in this.
I'm pretty certain
I haven't tried it in. And if it doesn't work, if you can't drag and drop a screen directly into Google Docs, you can always save the screen and then import the image. I will play with that maybe if we have a time.
Yeah,
later.
I am like 95% certain I did.
Okay. Yeah, I
stats teacher. I'm not going to say 100%.
So, okay, I'm sorry. There was somebody who asked about dragging and dropping into Google Docs.
Yeah, 99% on Google Slides. I'm trying to remember the last time I did it to a Google
Yeah,
Doc.
I can't remember doing it. I can't remember for sure, but I'm pretty sure you can.
Okay, I'm just going to quickly do a solving of an equation because there's one little trick, little nugget that I want to hopefully give somebody in this group about this, because as us being math teachers, and I'm just throwing this over on the side for a minute, we'll pretty up our screenshots and all before we repost our handout, would use the quadratic formula. And in your quadratic formula, you got your plus or minus thing, okay? So I need that fraction template.
What?
Yeah. He had my mouse. Okay. So I need my fraction template. It's not going to.
Yeah, I can't respond.
He can't do chat with.
I'm sorry. We're using Smart Notebook, Barbara. We're using Smart Notebook.
Yeah, and Smart View kind of together.
Yeah.
So on the top, okay, it's negative b, right? Okay, here's brushing off from summer. Negative b, and my b is 1. Now for the plus or minus part.
Oh, I know where you're going.
Okay.
What was she
so I'm going to do a little plus here, but we know we want plus and minus. I could type the whole thing in, calculate it, and then go back in history, grab it, and change it. But I'm going to do something a little bit different. I'm going to do it all in one shot. To do basically a plus or minus, use your little curly brackets, which is the second curly braces, which is your second parentheses. And did I hit parentheses? I'm going to make this bigger to make sure that we can see it.
Yeah.
And I'm going to put a 1 and then I'm going to do a comma, -1, and then close my curlies.
And then continue.
And then continue my quadratic formula. So I'm going to do, and I'm going to use the soft keys just to practice doing the soft keys, even though I don't have to. Number 6, we'll give you my little soft key. Oh, I didn't want to do that. That
No.
put, I did the soft key wrong. Sorry. Oh, all right, here we go again. -1 plus curlies. Don't get fancy, Tracy.
Yeah,
Don't
just
get fancy. This is fancy enough for me.
Yeah, come on.
I shouldn't go any more fancy than this.
Then do
So square root. Now I need to see my problem. So if you don't mind, I'm going to make this down again. So it is -b plus or minus b squared. So this is nice. It's just 1 squared minus 4 times my a times my c all over. Now notice I have to hit the right arrow twice, get out of the square root, and then get to the bottom. 2 times my a. What that plus or minus 1 has done, it's allowed me to do this once and get both answers from my quadratic formula.
And what it is essentially is it's actually creating a sequence of 1 and -1. So it's doing the formula with 1 in front of the square root and then -1 in front of the square root.
So you want to think about when you show this to kids. Definitely algebra 2. They've done the quadratic formula, you know, in quadratics, probably in algebra 1, algebra 2. They're ready to kind of take this extra little thing. It's just one of those. I just think it's really cool.
Yeah, Jim,
Really
you're
cool.
right. And there's little things that, I mean, 20 something years, we're still learning. I learned something new. Can I share something new that I learned
have to
last
share
week?
this.
Yeah, last week. Hi, what are we doing with up here?
Pay attention.
Okay, I'm sorry.
Opening up our pictures.
Sorry, I was in the wrong screen. I don't know what it would do with imaginary numbers. You'll have to try, Zachary. I'm going to do a least common multiple, but I want to do the least common multiple of 3 numbers. So what did I write down? I'm going to do 8, 12, and 15. Okay, those are the 3 numbers. But the LCM command only does 2 at a time. So there's 2 things I'm going to show you here. Math, and then go over to number, and there's lots of different things, but the least common multiple command is under the math number. But I don't remember how to use it.
Yeah, I haven't used this in forever.
Well,
so
there's 2 things under.
I use this thing.
Well, whenever you're in the menu on any command, you can hit the plus key, and it'll automatically give you the syntax help, catalog help for that command. So what this tells me is for LCM, I need a value A and a value B. That means I can only take in 2 numbers. Okay. Now I can easily escape out by pressing graph, or I can, now that I know how to use it, I can paste it in. So I'm going to hit paste, and then I'm going to do, my numbers were 8, 12, and 15, but I can only do 2, right? But within the LCM command, I can nest another LCM. So I'm going to go back to math number, and I'm totally stealing this from Jeff McCullough. So Jeff, if you're on, thank you. And then 12 and 15. So I'm doing the least common multiple of an 8 and another least common multiple. Okay, so this is, I mean, the ACT thinks they're really smart by giving you 3 numbers. Well, they're not so smart. I can just do this and pick 120 and move on. Okay?
Okay.
All right, so there's 2 things there, the nested LCM and the catalog help.
The catalog help. And this works on any menu that you're looking at. You want to select and find out how to use something. I mean, none of these are too terribly interesting. Maybe the problem. It will tell you what stuff has to come after it, the syntax to actually run that command. That to me is phenomenal. And we showed you about the nesting, and we showed you this alpha xt theta n. So
let's dump a screen here. All right, so I'm going to dump a screen there just for later.
Yeah, we want that sequencing thing.
Yeah, we want that sequencing thing in there, and we'll come back to it. So I think we're good with the home screen, and maybe we're ready to do some function graphing.
Sure.
Okay, all right. And I'm not going to do anything new here, actually. Wait, is this the same problem? Oh, you picked it. Okay, you got slightly. Oh, I think I know why you did this.
Oh, no, I should have been.
It should have been the same problem, so we want this to be 11. Or plus, we want this to be plus 1. Okay. Yeah.
I must have grabbed that from your notes or something.
Okay, yeah. So we probably messed up. This is my first mistake ever. All right, so a few minutes ago, Tracy used the the quadratic formula approach to solve this. We could do this a couple different ways. Let's graph and see what we have when we do this. So I'm going to go to y equals and put that in there. Should it be a minus 15 as well? Oh my goodness. Thank you for that.
Yeah, I really messed that
yeah,
up.
you totally messed me up
What
on
I was
this.
doing.
Thank you for that, Molly. You're a lifesaver. Anything else that I get? Yep, that's all right.
That's where
All right, so we're gonna get the same answers. They're not trying to be creative here, okay? We're trying to teach you some calculator tricks to make sure you know and love your calculator as well as you should.
And remember, depending what you're teaching, this is what you're going to do with the kids the first week. Brush their calculators off, get them back into the mode with things they have seen, and maybe with little tricks to add in there for them.
All right. So
All right.
Molly and the rest of y'all, thank you for helping me discover my mistakes. So we pressed y equals, and then we typed in the equation.
Mhm.
What are the kids going to do right now? What do you think? What should I do?
I know what my kids are going to do.
What are they going to
They're
do?
going to do Zoom 6.
Okay, they're either going to do a Zoom. They might just press graph and get lucky
Yeah.
if their calculators are new. But 99% of the time, we do Zoom. And a little trick, I think Tracy's been doing it really well too. I know. My kids will eventually say, Mr. Bobby, you can just hit 6. I never stop scrolling until somebody tells me, until I hear it a couple times, because I want to be the last one to press the enter button.
Mhm.
And I found out when I first started teaching that I was going way too fast in the calculator, and now I'm kind of stalling to let you catch up to me. So anyway, I would choose Zoom and then scroll to get there. So I'm one of the last people that gets there, and I know that.
And someone said a lot of their kids will do Zoom Fit.
They'll do Zoom Fit.
You know, they've got this thing, who whatever teacher they had before kind of showed them what they liked for their classroom. Okay. So.
And Josh was saying they were factoring. Josh, you have better kids than me. They're going to try everything under the sun besides
Not to factor.
Okay, now this one does factor, but not one of the solutions not perfectly obvious, right? And I can factor like the wind, and so can Tracy, because we're math people. And everybody on here, it's a Tuesday night in your summer, and you're online. Obviously, you're a math person too.
Yeah.
Okay, but we know our kids don't necessarily love this. Okay, so we're trying to give them some connection. All right. Now we already saw the answers were -3 and 5 halves.
5 halves. Yes.
Okay. You can also do, I'm hearing, okay, there's enough people who want me to do this. So I'll go to Zoom, Zoom Fit. Was somebody saying that?
Someone said Zoom Fit.
Okay.
Yeah.
I could do Zoom
Let's
Fit.
see what Zoom Fit does.
The Zoom Fit is, some people like that.
Yeah.
That's cool. Okay. So that's cool. But most people work in Zoom 6. Now, I personally, there's times I like Zoom 6, but I find it kind of offensive because every graph I've ever looked at in Zoom 6 is a lie. It's not proportionally correct. Your screen is roughly in a 3-to-2 ratio. So Tracy's heard me say this a gazillion times, and she's sick of me saying it, but too bad. And somebody I think also said this in chat with Zoom 4. Zoom 4 is nice, but it's too small. Okay.
Now, why are you saying Zoom 4 is nice?
Why I like Zoom 4 is Zoom decimal, is proportionally correct, where 1 unit along the X is the same as 1 unit along the Y. If you look at the distance is along the X-axis between the tick marks and the tick marks on the Y-axis, those distances are the same, and the graph is proportionally correct. If I were to graph Y equals X now, this graph would be make a 45-degree angle with the X and the Y axis. It's proportionally correct, as it should. If I do this in a Zoom 6 window, that is no longer a 45-degree, and it's a distortion of the graph. Okay.
And I'll tell you, I was right there with my kids saw distorted graphs all the time, and
it didn't bother me so much, and nobody likes this because it's too small. So here's my solution. What I do is I don't remember these numbers. I just go in here and I double all of them. And so I'm going to take, and I know I could do the math, but this is it's summer, and Tracy's been nagging me, and I don't remember how to multiply times 2. And I probably should be able to do the first one, but I'm doing this because you could triple them if you need a really big window.
Yeah.
Okay.
And so this one gives you close to the standard window, which we normally work on, but it's squared up.
Okay. And then some people do like the zoom square, and that's cool too. But I
Mhm.
like this because now my values along the X are still like in that negative 10 to 10 range. A lot of stuff and a lot of books happen in the negative 10 to 10 because they write the book for the calculator.
Yeah.
Okay. The Y mins aren't quite up to negative 10 to 10, but now this graph has proportionally correct, and it is similar to the zoom decimal window. Has some of the same action going on. Okay.
Someone mentioned the tracing is nice
Yeah,
too.
when you
I
trace,
like
yeah, and the
that.
other thing about zoom decimal is
Mhm.
when you trace on it, the trace numbers on the zoom decimal, the trace intervals were 1/10. Because I've doubled them, now the trace steps will be
Two tenths.
2/10. If you tripled them, it would be 3/10. Okay. Now I use this window a lot. This is my favorite window. And I'm ashamed to say how long it took me to learn this, but under Zoom, the
Yeah.
you,
You know, it's kind of annoying to have to go and change their window settings all the time when this is the window he
this
wants.
is the window that I like. This is my personal favorite. This is the one that I have fallen in love with. Okay. Because like there's math, there's dogs, there's calculator, there's my
Zoom
motorcycle.
decimal.
Then there's zoom decimal, double
And then
decimal,
maybe
then maybe
eventually.
Tracely. Okay. But then I can go to Zoom Store, and what I've done is I've saved this window. So if I go back to Zoom 6, now I got my offensive window, right? But if I go to Zoom Memory and go down to recall, my favorite, the love of my window life is now restored to me without having me to do that double thing again. Okay, so you do have one custom window that you can store. Okay, so what I want to do right now is I also want to show you, and I think I do want to go back to Zoom Decimal. I do want to fall in love with piecewise functions. Okay.
Yes.
So I'm going to skip the heart, and I could have tried to find the zeros. I know some of y'all would have done that. But what I want to do is I want to introduce you to a piecewise function. So if you press math while you're in the, I'm sorry, I was in the y equal, and I'm in y1. If I press math, I can go down to the bottom under the math menu. The last item will always be the numerical solver, and we should have done the quadratic. We could have done the numeric solve for that quadratic, although it would only give you one solution at a time. And boy, is that it's nice now, but I don't have time to do that.
Yeah.
I'm going to go to piecewise, and I'm going to make two piecewise function.
And if you didn't notice, when he hit math, he didn't scroll the whole way down to B. He scrolled up to get to the very bottom of that math list. So, little shortcut.
Little shortcut. Yep. Okay. So now I've got a piecewise function that looks like a piecewise function, and I'm going to type in two parabolas here while Tracy tells you a little bit about.
So,
something.
if you look at this, I mean, this is how the piecewise functions are in a textbook, where they're giving the equation and then he's going to type in the condition for that particular part of the function. And so it is really, again, getting past the how do I get this thing in my calculator to do what I want? No tricks. It's just a template. It looks like you've got it in the textbook. Now, I'll give you a little warning. When you do 3, you have to do scrolling. You won't see it. Okay. And right now, notice he has done -4 is less than or equal to x is less than or equal to. This is interesting. Look,
Yeah.
he has done a double inequality.
Yeah, compound inequality. This is acceptable in this template and really nowhere else. Okay.
Now, if you do not see under math scrolling up when you're in the y equals menu, that piecewise, you just need to update your calculator, because that is a feature now that is on its. I can't remember. It hasn't been too long, so you're not like way out there as far as getting updated. I would suggest, that's one of the things I like to do at the beginning of the school year is update all my calculators during those teacher days. Hopefully they give you a little bit of time. He is getting the X using the XT theta. He's getting the less than symbols. Where did you grab those less than and less than or
I
equal
use
to?
the test menu, which is second math, and those you would update your calculator using TI Connect. You would have to download it from the TI website and send it to your calculator. So we can help you with that at another time if you like.
Okay.
So I'm going to do another function for kicks and giggles here.
I don't know where he's getting these functions. I kind of do, but
Yeah.
I'm going to play like I don't. He's just picking these weird functions. The
Oh.
piecewise defined functions, nice to show you that feature.
Oops.
And
So-
now he's doing an absolute
Yeah, actually,
function.
no, I want to do, I'm sorry, I want to show you also can use the piecewise function. I meant to do this with one piece to do a function with restricted domain. You don't have to necessarily do a piecewise function. You can do a function with restricted domain. So I'm going to do absolute value of x minus 4.
So I'm going to think of the V shifted down 4, but he only wants to see a piece of it.
I want to see x,
reason.
and this is why I'm going to go from second test less than or equal to x, less than or equal to, then again, the test menu. And I'm violating my scrolling rule. Okay. So now I've got two equations in there.
Now I'm wondering why did he? Oh my gosh!
There you go,
This is why.
Well, that's so gross. Okay.
Falling back in love. He is sort of a heart.
Yeah, she didn't like my heart very much, but at least I used piecewise functions or a function with restricted domain. I'm not gonna lie. Domain and range was something I never really understood as a student. I just put all real numbers down for every question when that came up and was right. And it was good enough on everything else to get an A, but I didn't really understand domain and range until I started teaching pre-calculus. And then I kind of had to get it square in my head. Because we never do functions with restricted domain, and then they get to calculus and they have it all the time. So really, it's a more difficult concept, and I think this can help. Okay.
So I probably, with my students on something like this, maybe have not restricted the domain on absolute value, and then they tell me to, well, I only want you to graph it from here to here, and then you can naturally talk about the restricted domain.
Yep.
But I mean, that's just getting them to trace on it can help make those connections, with domain and range.
So in the olden days, you used to have to deal with the there was a workaround to make this happen, but with the piecewise function, you can get functions that you can enter functions that look like piecewise functions, and you can get graphs that behave like you intend them to.
Yeah.
So let me see, was there something else I wanted to do with this? No, I don't think at this point, but
Is that it?
I think so.
Okay. So I'm going to take over because his heart kind of looks a little sad.
Wow.
Actually, it doesn't look too bad, but I like doing a heart a different way. So I'm taking over. And so let's see. I'm going to go ahead and just turn these off.
Yeah, you can save my beautiful work by not. And yes, I probably should have made them pink or something.
Yeah, I was thinking that too.
You can save the work by just changing the inequality, turning it off rather than erasing
the equals on and off by just hitting enter on top of it, just because I don't want to ruin all his work. And so what we're going to do next is a little bit of geometry transformations. And so what we're going to do is we're going to do a connected scatter plot with these values. And I'm going to make this bigger so that we can see it. Again, we'll pretty up the Smart document before I PDF it and replace our blanks, basically blank Smart document, so things look a little bit better. I picked some values very purposely, and we're going to see what we get when we do a scatter plot of list 1 with list 2. So under stat, we're going to go to number 1. That's where you find your lists, where if you're going to enter data in your calculator that you're going to want to graph, this is where you're going to put them in an 84. So these are the numbers that I'm going to put. I'm going to go 4, 0.
So she's entering the numbers, and many of you are probably aware that you can, you might have data in there. If you need to erase data, you want to go on the heading of the list where it says L1, L2, press clear, and then enter, and that will erase it. There's a couple other ways. Oops.
Trash in there. So if you've got some data in there, if you go on top of your list and hit clear and enter,
That'll erase it.
That's going to erase the data that's sitting in your list.
Do not
Be
hit delete.
careful that you don't hit delete because you may not be able to tell with it so small. I lost my list too by hitting delete.
Kids will do that. They'll think they're going to
It's-
be cute, or they think that, they'll hit the wrong button.
Mm-hmm.
And so you need to know that if your lists are messed up, you can retrieve them. You didn't erase everything.
I can even make it looks like it's all gone.
Yeah.
I did all that work for nothing.
Yeah, you're going to say
But-
Josh is right. Josh was right. You're going to remind the kids like a gazillion times. It's stat and then number 5.
Set up editor.
Set
Set
up
up those list editors again.
Yeah.
And that's going to look like it doesn't do anything, but it says done. So
Yeah.
it did.
And
then
that-
if I go back to where my lists live, they're all back and pretty again.
Yeah, that's not the worst thing in the world, but it can be very annoying when students still delete it. They'll get it, and you would think, well, didn't I tell you this last year? But you know what? They're new kids, and you got to win them over again.
Summer, dusting things off.
Yeah.
And even then, we all have bad
Put your
days.
rest of your numbers in.
Yeah, we all have bad days.
Yeah,
so
they're going to do
it's no
that,
big deal.
and we need to get the other numbers in so she can do her geometric transformations. But they're going to delete it, and you need to be cool about it and be lovey because, nowadays we can't, we got to be sweet. So she's got numbers. The
Wow.
hardest part is she's got to ignore me and type the numbers in where the X's match up to the Y's, and I'm keep rambling on, and she's still trying to ignore me.
Okay,
All right.
so I'm going to take these numbers and I'm going to make a scatter plot of them. I'm going to get this graphically to see what we have in front of us. So when you have data and you want to look at the graphical relationship that you see between these two variables, we do a stat plot. So I'm going to go second y equals to get the stat plot area up. And I'm going to do plot number 1. You can do 3 different plots, and we're going to take advantage of the ability to do 3 of
Yeah,
them.
that's 4 fingers up, by the way.
Oh, y'all didn't see that, did you?
Yeah, it was on the camera.
Okay, oh well.
Yeah, you have a degree in math.
Oh well. I'm excited about what we're about to do. Okay, so the type of graphs that we have several options. The first one is just this regular old scatter plot. The next one is a connected scatter plot. Then we have a histogram, box plot, extended box plot, regular box plot, and then a cumulative frequency. We're doing 2 variable data right now, but I want to do a connected scatter plot. I put those in a certain order so something really cool is going to happen. My X list is going to be L1. My Y list is going to be L2 for right now. I'm going to make my mark the dot.
Oh, and I think we did these in the double decimal window,
Okay.
not the decimal window that I think was where we were at the end.
Okay, well, we'll fix that then
Yeah.
in a minute. And because we're falling back in love and hearts are usually pink, maybe red, we're going to go with pink, magenta. Okay, is the fancy word for magenta. So I've got my plot turned on. My lists are all set up. It's going to be color. So I'm going to do the zoom double decimal.
Right, my little.
So that is his favorite. So it's got over in the recall, zoom recall, again, zoom memory and then zoom recall to make sure. And this is the heart that I like, hun.
Yeah, you know what? It looks a lot like my heart.
Yeah, sort of, not really. So what I would say for something like this, to start this off with your kids, if you want to do this we're going to transform this in a minute, get them to draw some sort of simple picture in a first quadrant and use their own dots for L1 and L2. Tell them not to use too many and then just put their own data in, and then we're going to transform it.
And it's probably a little better to use something that doesn't have symmetry because some of the transformations might be harder to tell.
Yeah.
She's normally doing this with a flamingo, but I
had to dish the flamingo because it was, hearts are all about tonight. So
yeah. Anyway, but we can make transformations numerically.
mhm.
Okay, now we do transformations. Tracy's the queen of patty paper.
Love patty paper.
Loves patty paper. And I'm sure some of y'all do too. But ultimately, we want them to understand the numerical impacts of changing the X's, negating the X's, or negating the Y's, or switching the X and Y.
Yeah.
So let's try go back to the stat and then edit. We have all of the X values in the first column, all of the Y values in the second. What I would like to see is what happens if we take the X values and make them negative and graph the negative X values with the positive Y values. So what she's going to do is make a copy of L1 that becomes negative. Okay.
So I don't want to retype all those L1s and put negatives in front of them. I'm going to shortcut. I'm going to take L3 and say, I want this list. I'm sitting on the top of it, and I'm going to say, give me the negative of L1. So I'm going to use my negative key, and then I'm going to say L1. And if you notice, if I hit the second button and number 1, it's the second functionality of that numeric key. 1, 2, 3, 4, 5, 6 is all of that. Okay. And what that does is it negates all of my L3.
Okay, so it's just all
or
those
L1
yeah, all
into
those
L3.
So what now we want to do is we want to make a graph of L3, a plot of L3 versus L2.
Okay.
And we can do that at the same time because remember, we can do 3 graphs, right?
They didn't notice that. You know?
Oh, I'm totally not going to let you off on that, okay? Because my kids would never let me off on that. So now she's going to do a plot 2, which I guess is that many fingers. We're going to go and make a graph of L3, which is the negative X values versus the Y. And you probably need to have this like really spelled out. What are each of these lists?
Yeah,
So
I usually like write on my board what my L1 equals X, L2 equals Y, and then we talk about what we're going to do next.
Please don't make it black card.
No.
You can make it a different color, but doesn't have to be pink.
I want it to be blue. Navy's pretty good.
That's cool, but not a black card.
Yeah, I don't want a black card.
We don't want a black card.
Okay. And now my window is all set up, so now I can just immediately go to graph. And I'm going to see both of them.
So now what happened when you have the negative X and the Y? Well, of course, kids would hopefully tell you. Now, the only problem is with the symmetry, is this a reflection over the Y-axis or is this a translation? That's why you don't want the symmetry.
Yeah, you want to be careful. But this would be interesting to say, okay, we did the reflection, but is there another way to get this Navy one?
Then you could have said, then we could talk about doing a horizontal translation.
Yeah.
Okay. Now, the only problem is if you want to have 4 hearts, you can't, at least with plots. You have to do some.
Have like 3 plots, plot 1, 2, and 3. So little limited there. There are possible workarounds using background images and everything. But remember, we're trying to just have a little bit of fun with students at the beginning. Teach them a little bit, remind them of things that they've probably seen before, but it's been a while.
And
so
you see transformation, or you see scatter plots all the time with lists, but geometry teachers can use them as well. And that's why we wanted to bring this up. Now we could have negated the Y. What would have happened if do you want to do that, or you have to?
Let's do a shift instead.
Okay, I'm going to go try a translation.
Yeah, let's do a translation
or a dilation. How would we do it? Well, let's do a translation first.
Okay, let's do a translation. So let's take our original, and if I wanted to shift it down, say 5 units.
All right, so we want to shift down. What are we changing, X's or Y's? Well, up and down's Y, so we need to do the Y values. So we would need to take L2, and the kids could test this. You could say, okay, and they would figure, they could do it and try. So you can take the Y values, which are in L2, and subtract 5. Okay. And you could also have played around with this on home screen and seen the data. So now what she's going to do is she wants to keep the original X values, which is L1, and then the down Y values, which would be L4. You definitely need to have some kind of recording going on to keep kids square, okay? Or they need to be writing down what they're trying, okay? So, and if you use the bigger dots, you're just going to have a heart with like bumps on it.
Yeah. That's the only reason I'm not using, I like the smaller dots. So starting off with something they originally draw, I think kind of really brings it home to them. And so then they can move around what they've done and do, some of this exploring stuff. Do we want to shut the quote thing or not?
No, don't.
Okay. I think I have to pass it back to you.
Do you want to do a dilation real quick?
Sure. Yeah.
I mean, so we wanted to do a baby heart.
Okay.
Yeah,
that'll be cool.
We can go over and do like half of L1. So we could do 0.5 times L1. And then that would be half of L1 and then half of L2. Just for sake of completion,
Yeah.
because we didn't do, and then we would do L2.
And so we're doing a dilation with a scale factor of 1/2 about the origin.
About the origin.
Because I'm a geometry teacher.
So what I'm going to do is I'm going to turn this one to L5 and L6. And then L6. Oops. Wrong button. Sometimes SmartView and me have our issues. We get along, but other times we don't.
It's easier when you're on a smart board.
It is
you're
yeah.
punching the buttons right on the board.
Yeah. And then, so I would get the pink heart is the big one, is the original, and then the image is, or pink is the pre-image, and the navy is the dilation by a scale factor of 1/2. So students can play around. We still have the translated heart. Yeah. So, okay. Last thing, I know
I promised you one more thing.
One more thing was inequality graphing. Oh, by the way, when you're in the y equals, you can turn off all of the plots from the y equals here.
Notice how they're going from the white background to black background.
So they can, yeah, they're off. You can have kids that may accidentally be on. If those are ever on, that may cause you some problems, especially dim mismatch if you've never seen it.
Yeah.
So we also promised you the inequality, and I normally got like 7 minutes or so.
You can do this.
Okay. So under the apps button, this isn't where you go to play Fortnite or whatever the hot game is at the time. There are different things here. Some of them are for geometry, some of them for science. But what we want to do is inequality graphing. And when you do this, kids will play this game and they'll press it and they'll say, that's a really stupid game because it didn't do anything. Okay. So it looks like it didn't do anything, but it did. And with the CE, there are updates that allow it to be, it changes the way things graph. Okay. And you can tell because if you scroll up, you can see there's an
Not
x
just
equal
plot 1, 2, and 3 anymore.
There's x equals, we'll maybe talk about that in a second. And then there's quit app. It's much easier to get out of these applications than it used to be. So I know you're dying for x, and she's dying. What does x equals do? X equals 3. You always say you can't graph anything that's not a function. Well, that's a lie. You can totally graph a vertical line now.
Using the inequality. Gotta have that turned on.
You can have that inequality graph. And it does tell you on the home screen. You see it says inequality menu second calc. We can actually get in there.
Yeah.
But that inequality graphing allows you to vertical line. And then there's conics. It would let you graph conic sections as well. Okay. So I'm going to take my turn that back off. Okay. Just because I said,
we just had to show you that.
Yeah, she made me show. I would have gotten hit later.
How do we used to do it? We used a really steep slope.
All right.
You know, and fake the calculator out so it looked like a vertical line.
So what I've done is I've changed the way this graph. If I press the left arrow to go back onto it, onto y equals, I can choose to do, and I'll respect her pinkness. And I'm going to do, I can change the equal signs to an inequality. Now, there used to be shade above and shade below, but that really didn't do, so I'm going to do less than or equal to. So I want to be less than or equal to that piecewise function.
So now notice, I mean, there is this faking of this inequality stuff regular when you're doing the shading. This is mathematical. This is saying we are going to graph y is less than or equal to this. We are going to graph y is greater than this.
So I'm gonna, and I don't.
And the result is the shading.
And so what I'll have now, oh, I would help if I turned these on because she turned them off for me earlier. And that highlighting the equal sign or the inequality symbol now works the same as it did before. She disabled them earlier. Now I've re-enabled them. So when I graph it, I've got, well, I can see my heart, but I got shading below the double parabola, and above the absolute value. So what I really want is that it's there, but it's like, oh,
where's the heart? I just want to see.
Well, if you notice, it says second calc above. So if I hit second calc, I can go. There's the friendly calculate menu, but now I also have inequality, and so I can do the point of interest, or intersection trace where there's
Yeah.
multiple intersections. But what I want to do is the inequality intersection. And I'm going to make it pink because that makes her happy, and it's how you stay married. And you can do the intersection, or we could have done the union if I needed it. This is perfect for linear programming or all that stuff. Operations research was the school class in graduate school that I was working this really big problem, and it all collapsed down and worked out. And I was like, wow, that was beautiful. It was the first time I realized I was truly a math nerd. And it would have been so much easier if I could have graphed it all on the calculator.
Yeah.
But I do want you to notice, if I go back to Zoom Decimal, couple things. I did do the intersection. Oh, I got to do that I did do that union again. I'm sorry, the intersection is what I want. I did not do it. Second trace, inequality. There we go. Notice, it's kind of a little hard to see, but because the double parabola was less than or equal to, it's a solid graph, but the inequality for the absolute value is a dotted graph or a dashed graph because I chose strictly greater than. Of course, it doesn't really matter for this diagram, but you do, when you do the shade above and shade below in the y equals, it doesn't make a distinction between greater than or greater than equal to. The inequality app does, and that's what's beautiful about it.
And that's, I think, there's the mathematical and then the illusion. The math is giving the illusion. To me, that's better than the illusion to give the math.
So I'm sorry if we overdid the heart thing, but give us a hey.
25 years with this.
We're allowed to. Yeah, that's true. So what we're gonna do is one last thing. When you have an app in the transformation or conic, you can you can turn it off from the y equal by choosing quit, and it does quit. And it used to say uninstall. Uninstall, which scared the heck out of me years and years ago. But now when I go, that's how I turn off inequality graphing. Honestly, I don't mind having inequality graphing on almost all the time, though. So,
yeah.
I think we do need to.
Hey, Corey and Tracy, you guys muted yourselves. That's okay if that was what you wanted to do. But I do need to start wrapping things up tonight.
I think when I passed it back to you, it must have done it automatically.
No problem. So I know there's been some excitement about the webinar tonight, so please share your excitement and share your questions on any of the major social media platforms. As promised, we're giving away to one lucky winner tonight, a TI graphing calculator. The winner tonight is Lori Clapp. So Lori, congratulations. We'll be in touch next couple days, maybe a week or two, to give you some, or I guess get some more information from you as far as which calculator you'd like to receive. But congratulations. To receive a certificate of attendance, go ahead and click the link that appears in the chat window. Along with that is a link to the documents that Corey and Tracy used tonight. And as Tracy mentioned early on, if you check out the link and go to Tracy's link that she provided for her documents, and Corey's link as well. Sorry, Corey. It's going to seem kind of vanilla or plain, but as soon as give Tracy a day or so, and she'll probably start organizing all those screenshots, and those documents will look a lot prettier in a day or so from Corey and Tracy. Yeah. And if you're missing the certificate of attendance link for any reason, just hang tight. You'll automatically get a follow-up email, which will have a link to your certificate, a link to the documents, as well as a link to the recording so you can watch this at your own pace. If you're in need of any post-webinar follow-up, maybe you didn't realize that there was a TI-84 graphing calculator available, feel free to give us a call or send us an email. I know there was some questions possibly about updating your TI-84 to the newest operating system. I did check, and at least for the TI-84 plus CE for that model, the most recent update was in June of this year. So they may have done a couple extra tweaks since even maybe you updated last year during the school year. So feel free to reach out to us if you have any questions about updating. or how to receive that free operating system. Huge thanks to the Corgi crew. Thanks so much, Corey and Tracy, for I learned a couple things tonight, which is always fun for me. But I think a few of the people who were on tonight did too. There we go. Since this is now the second appearance, what's the Corgi's name?
Blue. This is Blue, the Corgi.
Blue.
Yeah.
Well, Blue, thank you so much for being with us tonight. And thanks so much to everyone for joining us. We hope to see you back online next week. Everyone have a great night and stay safe.
Good night. Have fun with your kids.